Hey everyone, welcome to the channel Code Mantra, straight to you by Akhilesh Dwivedi. So in this channel today we are going to start our first series, that is ML project series, and today we are diving into the really exciting and practical machine learning project, that is crop recommendation system. And the problem statement is we want to predict the most suitable crop based on environmental and social features. So let's imagine you are a farmer standing on your land. You have tested your soil, checked the weather, but now the big question is, what crops should I grow? So to tell the answer for this question, we are going to create this crop recommendation system using ML. So today the data set we are going to use is crop recommendation data set from Kaggle. It contains over 2200 entries means row, where we have the columns features like soil nutrition, sodium, potassium, and phosphorus, temperature, humidity, pH, and rainfall. And the target will be the crop means like coffee, maize, wheat, etc. And this is our data set. I will be using data set from Kaggle. I will link this in my description box. So let's go to our environment. So mostly I use the Google Colab environment for my ML projects. You can also take its alternative as a Jupyter notebook. I will be creating my new notebook. So let it load, and you can download it from here. It will be downloading the zip file, and from zip file bring you can directly bring the file. Okay, here you can after the zip file download, you can unzip it and bring this CSV file to your runtime environment. So it will be coming, and let's start our project. So first of all, we will be importing some functions, libraries, and modules. So it hasn't downloaded yet. Let me do once again. Yes, so it will be taking some time, but it will be done. So let's import pandas for bringing the CSV file as PD, and then we will be importing Matplotlib for obvious reasons, pyplot module, and alias will be PLT. Then for plotting the chart, we will be using Seaborn as SNS, sorry, SNS. And now uh, from sklearn, or it is also known as Scikit-learn, go to pre-processing module, and from there we will import label encoder. I will tell you later why we are using all these things. And then from scalar only model selection, we will import train test split function. So basically this function will split train and test from our data. Let's run this. Yes, so it has been run. And not every time you have to do this. You have to just press control button with a M and B, and your new code runner will come out. So let's load our data. Load data set. Mm, data frame equal to pd dot read csv. Let's know what is the name of our file. Crop recommendation dot csv. Right. Okay, let's see what our data contains. Just take entries. Okay, so we have sodium, phosphorus, potassium, temperature, humidity, pH value, rainfall, and label. So, yes, now let's move forward and get into pre-processing of the data. Let's see what our data frame has. Okay, okay, so the file name is, sorry, my mistake. Okay, so you can see that we have 2200 entries for each of the feature, and mean of each feature, minimum of each feature, maximum of each feature, and this if this is not percentage means 25%, 50%. It's the percentile. That means 25% of the entries are less than 21 value for nitrogen, 28 value for phosphorus. Likewise, 50 percentile and 75 value, as you have seen in the J-mains and other competitive results. Now we will see the information for our data frame. Okay, so here you can see that there are no null entries of any of the feature. So we not need to work with NA or NaN entries. That is good for us. Okay, so now we have to do the encoding of our target variable. First of all, let me show you what is our target variable. Features. Let's talk about features. Features are pH, nitrogen, phosphorus, potassium, rainfall, temperature, and humidity. Whereas target is label. Okay, so this is our features and label. Now let's do encoding. So for encoding, we will be using label encoder. So what we have to encode? So as you have seen that each of the feature like up to rainfall are numerical values, but the label is rise and other things. Okay, let me show you what are the other things I'm talking about. Okay, df dot label dot unique, it tells that all unique values of that feature variable. So see, rice, maize, chickpea, and all others, these are the categorical values. And if we talk about our a recommendation system, so mostly recommendation system works on numerical values, and so that these values convert into numerical values, basically we will be giving them indexes, and for that we are going to use label encoder. Okay, so what is our, yes, sorry, label. In this we will be fit transform, and what we have to transform, we have to transform the label variable. I don't know why this is happening. Yes. So now see what does our, okay, label consist. Hmm. So now you can see that all are the numerical values. And let's check what are these numerical values. Uh, Means how they have been mapped. So label mapping. Let's check it out. For this, we will be using a for loop in this. We have a index, our label in enumerates. I I think you know how this function enumerates work. It's the inbuilt functions of label encoder classes, and yeah. So what it will print? It will be printing F. F will not be printed. First of all, label and on behalf of that index. So let's run it. Yeah. So as you can see that apple is indexed as 0, banana as 1. So basically they have been indexed in the dictionary form. Okay. So as you can see that rice has 20 index means it has numbered as 20, and you can see that 0 index, first index, second index, all these are 20, and if you go above, that's 0 index, first index, where rice only. So from here you can take the idea, and let's move forward. Now let's see that whether our target variable has any imbalance or not. So it is important to check imbalance from our target variable, because if our target variable has imbalance, then it can bias the model towards the majority class. Okay, so let's say if rice has 90% of data. Okay, so most of the time when we predict a crop, then most of the time we will get rice only. So this is called imbalance. So it is necessary to check the imbalance from our target value. Okay. Oh, nice. So as you can see that each of the unique label has same counts of the entries. Okay, so there is no imbalance in the data. And now if let me show you something else. Yeah. So okay. So you can see that nitrogen, phosphorus, and potassium, these are complete integer values, whereas temperature, humidity, pH, and rainfall are float values, as you can see this. Okay, so most of the time they can lead to uh, they can decrease our accuracy, because between 2 points, means 20.1 to 20.2, they are infinite number of numbers, so that can make us difficult to make a good model. So for that we will scale our all these temperature, humidity, pH, and rainfall features. And that's why at the starting of the video I have imported standard scalar function. Okay, so let's get down, take a variable scalar, standard scalar function, and now scalar values. This will keep all the scalar values of the features like temperature, humidity, and all. Fit transform. So what was all? Data frame, and in this we have multiple features. That's why we have to take a array. So first one is temp temperature, next is humidity, humidity, other is pH, and at the end we have rainfall. Okay, I have made a mistake. Yeah, now it's okay. So, yeah, it had run completely. Now let's see what does this scalar values keep. This scalar value will be in the array form. Yeah. So as you can see that it's an array, but our data frame only contains data frame. Okay, the feature should be in not in the array. So for that, mm, sorry. Okay. So now we will convert this scale values array to the data frame. Okay. So how we will be doing this? Mm, Array data frame. Take another variable scale data frame, and in this data frame, this and pandas function data frame, which will take an array that is our scaled value. As you have seen above that it was an array. And then what are the columns? Means we are going to convert our array into data frame, but each of the particular array should have its feature name, means column, which column does that array belongs to. So we will give the names, and for that we'll be just copying it from here because that takes a lot of time. Columns. Columns equal to, okay, here we go. And we have to also reset the index so that the scale df can align with our original data frame. Okay, resetting index. So for that, what we will do, scale dot df equal to scale df equal to, no, we are going to reset index. So yes, and data frame. So it will reset the index values. And now replace scaled df to original data frame. Yeah. So for that, what we'll do, we will be copying this whole part, Control C, and keep it at and assign the value df. And here we go. Okay, where we had made a mistake, scaled, uh, scalar value. Sorry, not scaled value. Yeah. So now see how our data frame looks like. Yeah. So as you can see that our from above, these data were gone. Yeah. So these data were 20 point something, 82 point something, 7 point something, 206 point something, and so it was a wide range. So by scaling those data, we have brought them to the -1 to +1. They have compacted, they have compressed to a particular set, -1 to 1. And let's check. Sorry. Yeah. So now we are going to check map. so that we can know how this all works. Okay. Uh, we can get the clarity that how the features are related to each other and even to our target variable. Okay, so for that, as we have already imported our function plt from matplotlib figure, sorry, figure uh, fixed size. What should I take the fixed size? 10 by 6 will be great. Yeah, and we will be using heat map for this. Correlation means basically we are going to use correlation data set. Yeah, so the correlation heat map. Yeah, all values are numeric only. True, then and not equal to also true. And we will take CMap as a code warm. That will be the great. Yeah. Now, what will be the title of the plot? Correlation heat map. Now let's see how our plot looks like. Why we got an array? Okay. So I have cleared all the arrays I was encountering. Basically, these all were the typing mistake. So yes, so this is our main correlation heat map. So what this value says, it says that if, as you can see that this label and nitrogen has correlation of negative values and it's also quite low. So it says that if label increases, then nitrogen value decreases. Okay, so labels are just like rice, maize, and something else. So that doesn't matter. So if nitrogen value increases, that means less index crop will be recommended, will be used. Likewise, if you say rainfall and phosphorus, so if rainfall is higher, then phosphorus value will be less, and if phosphorus is higher, then rainfall will be down. So basically, rainfall doesn't relate with phosphorus, because if phosphorus is low or high, it doesn't matter what will be the rainfall. So but phosphorus is depends upon rainfall, because if rainfall will be higher, phosphorus value will be less. That's what it is saying. Now if you will talk about humidity, okay, so if rainfall is higher, and here you can see that this value 0.094 is a positive one. So if rainfall will be increasing, then humidity will also be increasing. Likewise, humidity and temperature, you can see that if humidity is higher, then temperature also increases, and it increases more than the rainfall. Means if humidity is higher, then rainfall will be higher. But if humidity is higher and temperature will be more higher, because its value is more than that 0.094. So likewise, you can see this table, and looking into the table, I can conclude that the features all we have is not linear, because you can see the mapping. Okay, so that's why logistic regression will not be helpful for our model, and thus we will be using random forest, because that will be the best for our model. And yes, so and yes, random forex mostly work on the complex and non-linear relationships. And you can see that none of the features have linear relationship mostly with their other features, and even with the target variable. And the data is also complex, and it's a huge data of 2200 entries. That's why we will be using random forest. So okay, so now we will be splitting our data set and we are moving towards creating our model. Creating model. Yes. Now we'll be creating our model. Data set in features and target variable. So X value will be TF and features are more than one. That's why we'll be using an array. And here we have temperature, temperature, pH. It's like that. Okay. Yeah. pH, then nitrogen, phosphorus, potassium, humidity, okay, so we start with features, and for that we will taking and more than one feature we are going to take. That's why we will be taking uh, an array, and in this we'll be having nitrogen, phosphorus, potassium, then temperature, humidity, pH, and one more thing, that is rainfall. Make sure that the naming is correct, otherwise you will get an error. Uh, for target variable, we will be having only label. Yes, yeah. So now we'll be splitting our training data and testing data. Split and test data. Yes, so extrain, x test, y train, y test. So these will be variable, that is X training data, Y training data, X test data, and Y test data. And yes, so we will use our train test function that we have taken from Scikit-learn model selection, and we will use the X value, Y value, and the test size. Mm, Mostly we use 20% of the test data, and random state should be, means how random we will be taking our data, that be 42, because it's a huge 2200 entries data. That's why we will be taking 42 as random state. So we have also split our data. Now we will be training our data. Yeah, now train our data. Train data. Sorry, train model. For that, our model will be equal to random top for a random forest classifier, and in here the random state will be, we will be taking 42 only, because above also we have taken 43. Okay, so what is this random set? So it's a parameter in random forest classifier that results that ensures that results are uh, producible. Okay, and it assembles the decision trees, that how randomly subsets of data and features we will be taking. And either we can take 43 also. It matters all upon us. Now we'll fit our data set. Okay, now we will fit our data to this model, and through this our random forest classifier model will learn, and it will train the model. Yeah, what happened here? Screen white. Okay, yeah. So we have not imported our random forest is from scalar ensemble import. We will be importing random forest, and to see the accuracy and other details we'll be importing scalar matrix import classification report accuracy score, and also confu confusion matrix. Yeah. Okay, so now our model will be created. Yeah, so as you can see that our model has been created. Now, let's predict our test data, what we are going to get. So model predict test data we will pass here, so that we can get the web prediction. And now we will print all the details, that how much is our accuracy, precision, and recall, etc. So for that, classification report, and we will take a line from here. Next line our classification report will be classification report, and here we will pass y test and y predict. Yeah, and next we will be printing accuracy, and accuracy will be accuracy score y test comma y predict. Yeah, now let's check out how much is our accuracy. Oh, good. As you can see that our accuracy is 99.31%. Okay, and the precision shows that how many times we have uh, predicted a correct levels from our model. So as you can see, it's very good, very good accuracy, 99.31. Let's sometimes if we change our random state from our random forest classifier, that also makes some difference. Let's take 47 here, and now if you create the model and see accuracy. Okay, so accuracy has changed here, but not overall. Let's take it as 45. Okay, from, so basically it will be our last accuracy that we'll be getting from our data. And now what will be going? We will sing the correlation map. Sorry, mostly it happens. So we will be seeing our correlation map of the confusion matrix. Okay, so confusion matrix equal to confusion matrix y test y predict, and then we are going to see the heat map. Yes, CM will be our data, and anode will be true. So then FMT, I think will be D, and CMAP will be blues. Yes. What should be the X label? Uh, X label is prediction reality dot Y label actual reality dot title will be confusion matrix heat map. Now let's see how our plot is ready or not. Yeah, so our map is already ready, and this is how it looks like. So as you can see, for the prediction of zeroth uh, zeroth level, so none of the time it was wrong. Every time it was correct, correct, correct. Yeah, so as you can see that the 10th level, it was once predicted as the 13th level. So yeah, that's why we got 99.31% accuracy. Otherwise, all the where you can see is zero, means none of the time the prediction of the model was wrong. So here was the last, and let's see that where we can implement how real world can impact from our crop recommendation system. So with this model, we can help farmers make smarter decisions, boost agriculture productivity, contribute to sustainable farming. So yeah, basically machine learning is very good thing to start with and make a career on it. So I hope you have liked the work I have done here. And if you enjoyed this project, leave a like and don't forget to subscribe for more ML content and other tech contents also. Also, the full code in the description if you want to try it out yourself. Thanks for watching, and as always, stay curious, keep coding. See you in the next video. Bye.